Okay, can everyone see my screen okay? Matt, maybe you could confirm if you can see the slides okay?
Yeah, I can see them fine.
Perfect. Yeah, so thanks, Matt, for the introduction. As Matt mentioned, my name's Ben. I'm the VP of Engineering at Theodo, and today I want to talk to you about building event-driven serverless applications using EventBridge, and particularly EventBridge Storming, which is a workshop technique we use at Theodo. And I particularly want to talk about an open source tool I'm working on at the minute with a team called sls-dev-tools, and how that helps you when you're building event-driven serverless. As I mentioned, I work at Theodo, which is a startup that helps other companies build digital products and large companies achieve digital transformation quickly. So we're split across a couple of companies in London, Paris, and New York. And my role at Theodo is the VP of Engineering. In addition to that, I'm an AWS serverless hero, as Matt mentioned, which means I get to spend a lot of time with the community and get to work on things like organizing the serverless meetup in London with Ant Stanley and a couple of open source initiatives around serverless, including the Serverless Transformation project, which is a blog on Medium. Feel free to check it out. Some of the articles cover a lot of the topics we're going to talk about today. There's also a Serverless Transformation newsletter. All the links are on this, and I'll share the links to the slides afterwards. And there's a Serverless Transformation book in progress at the minute, the first chapter of which is available freely online, and any feedback on that would be amazing. Do feel free to follow me on Twitter. All the initiatives that myself and Theodo are running in the serverless space are all shared through Twitter, so feel free to give me a follow. Today, we're going to be talking about event-driven serverless, EventBridge, and sls-dev-tools. But before we jump in, I'm sure a lot of you will have views on how we define serverless, but I think it's a good idea for us just to go in with a shared definition of the term through the talk. So what is this serverless thing? Well, in my mind, it's an architectural movement. As AWS would say, it allows you to build and run applications and services without thinking about the underlying services. More pragmatically, it allows developers to send application code, which is run by a cloud provider, and sort of isolated containers with all the complexity of how to run code and how to scale code abstracted away from the developer. There's also importantly the use of third-party services for managing things like back-end logic and application state. For instance, Firebase or Cognito for identity as a service, or outside of AWS, you could use something like Okta for identity as a service. Confusingly, it's also a framework with the same name, which makes talking about serverless sometimes a little bit confusing. In this talk, we're really going to be talking about serverless, the architectural movement, rather than serverless, the framework. Why do companies adopt a serverless approach? Well, primarily it's a cost reduction. There's a huge cost reduction or huge potential cost reduction in running your applications, but also a massive reduction in the amount of ops work that's needed to set applications up and keep them running. So the total cost of ownership of serverless can be a lot less. There's also more focus on delivering business value from the development teams, as they're focusing more on building features and less on running the architecture. And it's scalable from day one. And as we start to make more efficient use of the servers in our data centers, it also means that these data centers might start to be a bit smaller or grow at a slower rate, which could reduce the climate impact of these data centers, which at the minute produce the same amount of CO2 as the aviation industry and are just growing. It's not just Lambda, as I alluded to earlier, it's all the different components that make up an architecture. So Lambda is sort of the poster child for serverless. It's the function as a service compute element from AWS, but you need other things to build a serverless architecture. S3 for storage, DynamoDB as a completely serverless database, API gateway acting as an API proxy, Cognito for identity as a service, SQS for a simple queuing system, step functions for workflows, EventBridge, which we'll talk about in detail today, and many other services comprise most AWS serverless architectures. So not just Lambda, and that's probably something to keep in mind. In terms of Lambda specifically, though, there are many different things that trigger Lambda functions in serverless architectures. We've moved away from sort of the request-response paradigm and a lot more into different cloud events between different services and integrations working that way, which is something I'll expand on later in this talk. So with these different serverless components, you've got a lot of power and flexibility in the architectures that you build. But once teams get past sort of the first trial of maybe running a PDF generation at a Lambda function, and start to sort of take a serverless first approach to building out their architectures, they sometimes struggle in seeing what this looks like. A lot of us are familiar with microservices, or are familiar with the term at least, this idea of sort of creating logical separations in the services that we're building. Just one point, and it's something that I think gets confused, is that a Lambda function is not a microservice. A Lambda function or several Lambda functions and a DynamoDB database could make a microservice. Lambda functions with S3 and SQS with step functions, that could be another logical microservice. But not every Lambda function is a microservice. There's still groupings of Lambda functions and grouping with other services. AWS services, which help you build this concept of a microservice. And this is something we'll jump into how to build later on in this talk. From my experience and also sort of the general guidelines that are out there, microservices work well when there's a clear split between services, when they can be deployed independently, and when they only communicate with each other through asynchronous events, as I'll come on in this talk, but generally not through synchronous request response. They also master their own data, so not having a shared database between microservices, but letting each microservice maintain the data in the structure it wants, allowing services to be deployed independently and teams to work independently at speed. And this is nothing new. So service-oriented architectures, SOA, was a movement that preceded microservices and had many of the same tenets that we're seeing in sort of modern day best practices with microservices. For those of you who weren't around for the SOA days or never got the chance to play with them, SOA architectures often made use of an enterprise service bus, an ESB. This allowed the connection of the different services in their architecture to communicate with each other in sort of a centralized event bus pattern. Breaking down the term ESB, the enterprise part implied that it was used in these large enterprise organizations, as it was often used to tackle these very complex domains, and historically there was a large sort of infrastructure investment needed to set up an ESB. The service part of the term ESB comes from the fact that it's providing this communication pathway between the different services. Services here being logical, self-contained representations of different business processes, allowing them to communicate. And finally, the bus part refers to sort of the hardware components of computers that I'm sure a lot of you will be familiar with that allows the transfer of signals between the different components. Here, this bus is allowing the transfer of signals between the different services that compose an overall architecture. I've mentioned the term event-driven, and that's what we're going to be going into in the rest of this talk. And I think it's important that we define what an event means. An event is really a significant change in state, be that from a business point of view, such as withdrawing from an ATM, or purchasing something online, so placing an order, and also more in the technical sense. But in this talk, we're really thinking about domain events, those business events that make up a company. And this is where EventBridge comes in. So Amazon EventBridge is a serverless event bus that connects your application data from your own applications to software as a service and also AWS services. It allows you to connect the different services that make up your architecture, as well as connecting in different AWS events and also events from third parties. It's been viewed as the biggest serverless announcements since AWS Lambda was released, and is the key component to building state-of-the-art serverless event-driven architectures. Some of you might be thinking, well, actually I'll come on to that in a second, but some of those might be thinking, have we created the enterprise service bus again? Well, we haven't really, because there's several key differences when we talk about EventBridge being used to connect different services. It's completely serverless, so there's no management required. There's none of that large architectural investment needed in setting up the ESB, and it's very simple integrations between your own services, different AWS services, and third parties. Two key differences from typical ESB. If we jump back here, we can see what this looks like. So EventBridge is a service that can contain multiple event buses, be that the default event bus, which is the bus through which AWS events go through. So those CloudWatch events that we've had for a long time, nothing's changed there. It's the same underlying system, just being consumable through an event bus in EventBridge. You can also create custom event buses. So this allows custom events from your application architecture to fly through. So order purchased, payment failure, payment success. These can go through this event bus and trigger different services. And one small point that I added to this talk, just as we were setting up the call, EventBridge even works with Amazon Chime. So all the AWS services are really working well with EventBridge. So you could even have a Lambda function that's used to download the transcript of a call after it's finished. Really, EventBridge links into all the different services in AWS very well, and the list of services that are supported is growing rapidly. But why do we try and take an event-driven approach, and why are things like event bridges or event buses useful? Well, they help us avoid the Lambda pinball. So the Lambda pinball was an architectural anti-pattern highlighted by ThoughtWorks a while back, which is sort of the result of an architecture building up a tangled web of Lambda functions, S3 buckets, SQS queues, step functions, and requests sort of going in, bouncing around a sort of pinball, and then something coming out the other end. Typically, these were very hard to test. They're also very hard to sort of keep adding new functionality to, and led to a lot of sort of a tightly coupled distributed monolith, which is very hard to work with. Taking an event-driven approach and using a service like Amazon EventBridge and structuring it, as we're going to see later in this talk, really helps us avoid this tight coupling across our different services in a serverless architecture. But how do you start? How do you go from, okay, we've got a PDF generator now running on our Lambda, let's move our whole architecture to an event-driven serverless architecture? Or how do we start a new project in event-driven serverless? Well, there's luckily some stuff from the domain-driven design community that's very useful to us. So domain-driven design is quite a big area. There's quite some amazing books on it, but it's quite deep and quite complex to master. Event storming is one extension of domain-driven design that's really useful for building event-driven architectures. So event storming is a workshop-based approach that allows you to discover your domain events, the events specific to your business context, and find the boundaries between the different services in your business, as well as the entities and the aggregates. And aggregates is something I'll come on to in a bit later. At Theodo, we tend to use another variant again on event storming called EventBridge storming, which is a specific variant of event storming that reduces rework and tight coupling for teams building state-of-the-art event-driven serverless architectures. So EventBridge storming takes many of the same lessons from event storming, but applies them very specifically to building serverless event-driven architectures, and adds a few more steps at the end to take the learnings from the event storming workshop and encode them into your architecture directly. It's comprised of 8 steps. So event discovery, where we discover the set of domain events, through to temporal sequencing, where we put the events in sort of a logical order in terms of time, trigger detection, where we find the commands and the action and the actors, which is not necessarily needed for all architectures, and actually we're going to be skipping over today. Categorization into aggregates, so finding the names of things, finding the entities, order, payment, giving names to the different concepts that are coming through in these events. Categorization, again, into bounded contexts. We'll come on to defining bounded context later, but it's sort of finding the boundaries in your system. And then naming microservices. This is where we're starting to deviate away from event storming, creating the single event bus inside of EventBridge, and then building a shared schema and using the EventBridge schema registry to share this schema and enforce it. So let's go through each step. So the first step is event discovery. And as I mentioned, event storming in the first part of this EventBridge storming is an in-person whiteboard exercise with loads of post-its. Now, obviously, in-person isn't always possible, especially these days, but there are online tools like Metro, Retro, and others that make it very easy to share a virtual whiteboard space. The key to the event discovery is that we have people from the technical side, but also people from the business side and subject matter experts to help us elaborate all the different events in business terms. Now, these events should focus on the verbs, so the doing words, and should also be in the past tense. So basically putting these post-it notes, not focusing on grouping, not focusing on sequencing, really just getting everyone in the room to participate, putting events onto the board. This can take an hour, this can take a bit longer, and this is generally done in person or using an online collaborative tool, but everyone should be contributing, and it's really not focusing on cleaning up, just focusing on getting those events onto the board. The next is temporal sequencing, so putting things in order. As a group, we go through all the post-it notes everyone's put on the board and start to put them in order. For instance, an order needs to be placed before the payments can be successful and before the order can be dispatched, or a help ticket must be opened before the item ticket can be returned, putting them in a logical order with time going from left to right. Now, this is a collaborative effort again, and you can sort of find the missing events during this part and also get rid of any duplicates on the board as you're going through each event as a group. We skipped over the trigger detection and went straight to the categorization as entities and aggregates. Now, to take a moment on entities and aggregates, domain-driven design is very specific about what comprises an entity, and an aggregate being a collection of entities. And this is super useful when we're thinking about the data modeling side of things. But in this EventBridge storming, we're really just focusing on the events and trying to figure out our system boundaries. So if it's easier for the team, and if that team's composed of people from the business side as well as the tech side, maybe just talking in terms of entities is quite useful. We can bring up aggregates, it depends how you want to work. But the key here is to find the nouns, the names in those events, and using a different colored post-it note to put those onto the board. Now, formal event storming has stricter rules about the colors of the post-it notes, as we're not putting all the different types onto our board and really focusing on the events and the entities. I think it's fine just to use at least 2 different colors here, but then putting those entities near the events that involve them. And you can put the same entity twice if it's involved in quite different events. Once we know our entities, it's time to categorize the bounded contexts. Now, bounded context is a slightly complex term from event storming and domain-driven design. It's a context in which a term can be used ubiquitously. For instance, booking might have a different meaning in order management than it does in HR, and therefore there are 2 bounded contexts for the same term. This is quite a nuanced concept, and in very complex organizations can be very useful. But more pragmatically, for smaller scale projects and applying this on sort of all greenfield serverless projects, we find it useful more just to think about how can we build boundaries around the events that we've put onto the board that are logical and don't have a lot of interdependency. Your key here is really trying to optimize to avoid any interdependency between the different services, because that later will turn into temporal coupling, requests between these services, maybe synchronous requests between the services, which really leads to a tightly coupled system. Before we go on to the next step, step 6, which is the naming of the microservices, just another reminder that a Lambda is not a microservice necessarily. Now, in some weird edge cases, you might have a microservice that is composed of just one Lambda function, and some people put more into a Lambda function than others. But really, when we're thinking about an architecture, you're thinking about the grouping of different components that make up a service, and a service being a business process. Now, a business process normally has state, so it would involve something like a DynamoDB database, might have a few workflows, so it involves step functions, might have some queuing logic, so involved SQS, and might have a number of different things that need to be computed, so involving a number of different Lambda functions. But we need to logically group these things together. We don't want to think of every Lambda as its own microservice. We'll often then end up with a shared database or code that isn't particularly structured well. You really want to think about what the logical grouping of the different elements that make up your service are, make those groupings, and then finally group them into your overall architecture. So going to step 6, naming the microservices, one bounded context, or one of those big circles that we drew on the board here, one of those big circles could compose multiple microservices, or could be composed of multiple different microservices relating to the different aggregates and entities inside. And if one entity or aggregate appears in multiple bounded contexts, for example, orders have some relevance to the order management, but they would also have some relevance to finance, there should be 2 independent microservices to handle the divergent business processes. You don't necessarily want to build one sort of order service to rule them all. You want to let each service process orders in the way those services need to. Now, they're going to know about all the other stuff going through the system because we're going to have a formalized set of events going through that any of these services can subscribe to and listen to, and basically have those events trigger their own logic, but they should maintain their own data. Otherwise, those 2 teams are going to have to coordinate a lot, and we're going to have some coupling across those 2 different services. The next step, step 7, is creating the single EventBridge event bus. So we often say one bus to rule them all in our architectures, because having one bus means that different teams don't have to coordinate in terms of knowing which bus to subscribe to for the different events. Now, you do need to think about things like throughput that's going to happen on this event bus, and it is a bit confusing. Now we have SNS, Kinesis, and EventBridge, and there are some great articles comparing when different ones are useful. But generally in your system, for the business level events, yes, depending on the frequency, but in general, using EventBridge with a single event bus is a great way to build a decoupled event-driven architecture. And if you do have one bus, it really simplifies the coordination between the teams, as once you have a shared schema of events, they don't have to think about the different buses they need to subscribe to, but have one place to pool business events. So yeah, I think I just alluded to that. But then step 8 is building that shared schema. So teams should be able to work independently and deploy their services independently. That's one of the first tenets of building good microservices. Teams, though, do need to have some agreement between them on the structure of these events, their schema. So what's the title of an event? Is it order placed? Again, I think the past tense is extremely useful when we're talking about events. What's the structure? So what do we need to have in this event? How is it structured? And importantly, what are the types, especially for things like date and currency? But with other things, having a good understanding of what the types are between the team is extremely useful. Teams should really focus on sharing this formalized schema, not sharing data and not sharing code, and also not sharing API interfaces. We don't necessarily want teams to be able to be calling them each other through an API synchronously a lot. We really want them to publish events for the things they do and listen to an events the things other teams do, maintaining their own data about what's happening and executing their own computation about what's happening. The EventBridge schema registry, which is still in preview and only available in some regions, I'm sure will probably be rolling out wider, is extremely useful for dealing with these schemas across teams. In an AWS account, you can go into EventBridge and you can upload your schema, which you may have written in something like TypeScript or as a JSON, and then that schema is accessible to all the other teams. The other thing that's quite interesting is schema discovery, which is where EventBridge schema registry will build a schema for the events flying through your system based on the instances of the events that it sees, which means retrospectively it'll build up a schema, and then let's say the marketing team want to know the different events the order team are publishing, they can then look into the EventBridge schema registry and discover different events that team are publishing, and therefore they could then listen to those events and trigger their own logic of it. For instance, after an order is placed, maybe you want to send a marketing email to get feedback. Well, you could listen for the order placed events and then send your email. But what you don't want is that team to have to check in with the other team, or for them to change their API to be able to do this. You want them to be able to go to this centralized schema, see the event that happens when an order is placed successfully, and then trigger their own specific logic after that as a separate team deploying separately. So in sort of conclusion, and sorry if I went through a bit quickly to that EventBridge storming. EventBridge storming is a specific variant of event storming, which comes from DDD, that reduces rework and tight coupling for teams building state-of-the-art serverless event-driven architectures with EventBridge. And we're really seeing EventBridge being super useful in building these serverless event-driven architectures in AWS. If you want to apply some of that sort of 8-step guide to building these event-driven serverless architectures, do check out the article on Serverless Transformation, where I go into how you can build these event-driven serverless articles in a bit more detail. The link's here, and I'll share the link to the slides after the talk. And also feel free to drop me a DM on Twitter if you have any specific questions about applying this in your company. Now we've gone from sort of the process side and talked about the different AWS services and how you can sort of apply them in building a new event-driven serverless architecture. I think I'd like to talk now a bit more about the technical side and get a bit more into code. There's a project we're working on at Theodo, which is a completely open source project called sls-dev-tools that you might see me be tweeting about. It's a tool completely open source that provides in-terminal feedback with simple visibility on targeted metrics to development teams. It's not a replacement to sort of formalized observability tools like Thundra, Epsagon, or Lumigo. It's really a tool in the terminal, in the developer's IDE, via a terminal, for that developer to be able to get targeted metrics in the terminal to reduce the feedback loop, because developers writing backend code shouldn't really have to jump to the web browser on the AWS console every 5 minutes to check different things. It looks a bit like a tool from the 1980s, maybe the 1990s, showing you an overview of your Lambda invocations, the duration of those Lambda functions, and also things like how you're deploying. And I'm going to show in a live demo at the moment, in a minute, the different event buses you have under your event bridges. Sorry, the different event buses you have under your event bridge, and how we can maybe trigger different events on those. If you are interested in the project, after I give the demo in a moment, do go to the GitHub page. The link is here, and again, I'll share the link to all the slides. The team are really looking for feedback, so do open issues, and the team are closing issues very quickly. Feel free to open a pull request as well. And do star the repo if you want to give the team a bit of motivation. You can also follow the @sls-dev-tools Twitter account. Every time they're releasing, they're tweeting on there the new features, and also trying to get feedback from the community on what the missing features are. And one other thing to note, our CTO, Clément, tweeted out today that he's more on the Azure side than me, and he's using Azure function to get a GitHub webhook that's then sending him and the team a GIF and a message via email every time someone stars the repo. I think that was him playing around with Azure a bit, but also trying to give the team some motivation. So if you do take the moment to star that repo, you will be sending a random GIF to the team. So I think that motivation might be enough for them to get a few more votes. Cool, so I think that's all the links and stuff. I was going to do the demo directly in the terminal, but I was having a few AWS credential issues before this talk. So I'm going to share via a video. The resolution should be good enough once this opens up and starts playing. Is that coming through okay in terms of resolution, Matt? If you can't unmute, it's fine.
Yeah, no, I'm seeing it absolutely fine.
Okay, perfect. So this is a tool that you run directly from the command line. You can install with npm, so npm install sls-dev-tools, or this is of course documented in the GitHub repo. And once you run it passing the AWS profile you want to use, otherwise it'll use a default profile. The deployment framework you're using, by default it's serverless, but you can also use SAM. And all of this runs off CloudFormation. Runs off CloudWatch. So it's not really tied to the infrastructure as code tool that you're using. Once you run that from the command line, you'll then be displayed with this terminal in your command line. So you can see in the top right the list of different Lambda functions you have deployed in your stack. You can then open one of those up with enter. You'll see the invocations in that line chart on the left. You can see the server logs, which are hot reloading, and you can see the duration in milliseconds of the last 5 invocations, as well as a very 1980s map of which AWS region deployed to. You You can then use the tab key to navigate down to those different event bridges. Pressing I will allow you to inject an event where you can give the detail type, the source. So here the hello function is listening to the source custom.hello and isn't doing anything with the detail body, although we might just give a detailed type of test, I think. And once we submit this, this will inject this event into EventBridge. We'll see the server logs moving, and we'll also see another duration in that bar chart. Cool. So we're seeing that duration come through, showing the Lambda function has been triggered, giving us very fast feedback. And we're also seeing the logs are updating. Now the team are working on expanding this so it links into the EventBridge schema registry, so you can see the different events structures that are in your application, making that a bit faster. And this is quite a key pain point, because as we move to this sort of event-driven architecture with EventBridge, we no longer have the sort of HTTP endpoint that would use our typical tools like Postman or curl to hit. It's very useful to be able to do this in just a couple of key presses rather than writing your own script every time. And also it's useful for developers to be sort of really focusing on that schema to be able to write and debug their applications. By pressing I, they will be able to see all the different schemas that are shared in their teams, click on one of those schemas and inject an event. And making those schemas first-class citizens in sort of your architecture is the first step to doing event-driven in serverless really well. So do raise any feedback with the team. All the code is, of course, open source, so feel free to make any comments or also make a pull request. And yeah, the team are really open to issues on that, and we're finding this quite useful in our event-driven serverless teams, which have used those steps I showed you before to set up to allow their developers to be empowered by serverless and move quicker with it. If I jump back to the slides. Cool, I think that should have come through again. Sorry about that. Actually, that's the end of the talk. So I've been Ben. Thanks so much for listening. Feel free to follow me on Twitter. One of those QR codes takes you to the blog. One of them takes you to the newsletter. I'm not sure which is which, so feel free to subscribe to both. All the slides are available on slides.com/Ben Ellerby. I'll share the link in the Chime chat in just a second. And if you have any questions, I think we can use the Chime chat to maybe ask those questions, and I can see if I can try and give you some responses.
Cool, thank you very much, Ben. It's the hopefully you'll be able to see any questions coming up in the chat. People are free to unmute themselves as well if they want to ask a question out loud. See, there's already one that's come in, which is sort of asking what's the best place to get started with EventBridge?
Yeah, it's a very good question. It's obviously quite a new service. So, you know, people are still writing content. I do have an article I wrote a little while back here, which I'll share in the chat. And Sheen from Lego, Sheen Brizzles, has written a very good article on EventBridge. Inside the article I just shared is is a video by one of Amazon's experts on EventBridge, which sort of talks through how it works and the basic getting started steps. It's all also supported in the serverless framework. So if using the serverless framework, it's quite easy to get up and going quite quickly. One thing to watch out for is the serverless framework will create an event bus for you by default if you say a Lambda function is triggered by an event bus, an EventBridge event. But that can become a bit hard to manage as different developers deploy, and it's normally a bit better, maybe in your serverless YAML in the resource section, to create your event bus manually. I say manually, to state that you want to create this resource and then reference its on in the trigger for the Lambda, then have the serverless framework create it for you by default. It's a small thing to note, but it helps speed up some of the teams that I've worked with by managing that as a separate resource and then using it when they need to, rather than the serverless framework creating it based off the events that they have.
Well, there seems to be a few more questions coming through now. So in case you can't see them, there's one that's basically asking around, trying to understand the difference between things like Kinesis versus EventBridge. How can you choose which of those tools to use? And then a separate one just talking about EventBridge security.
Yeah, sure. So in terms of the Kinesis versus EventBridge, it's a very good question because, and even CloudWatch events, like people have been doing EventBridge, event-driven serverless before EventBridge was released. And if we take CloudWatch events as an example, that's you were sort of able to create your own custom events in CloudWatch events, and the default event bus in EventBridge is the same underlying technology as CloudWatch events. So it's not as if it's not like it wasn't possible before. EventBridge, though, provides a lot better tooling for using it. It's linking in with better observability. That's still coming, but it's getting better. And it's a lot more sort of friendly for teams to use as their communication path. Kinesis, though, is a lot better when we're talking about high frequency or high data volume. So, you've got a live stream of click events from your website going through a Kinesis stream and into some sort of data science team, it can be better to use Kinesis there. But EventBridge is generally better to have those domain events going through. And I'm just seeing that question about ordering. So yeah, the ordering is a complex topic. I won't go into a huge amount of detail here, but I'm hopefully working on an article trying to explain this a bit clearer. But yeah, you kind of need to build your applications somewhat sort of. It's difficult with some events, obviously, but generally to take the events in the order they're coming and have the application working around those. It has caused a few issues for teams that I've seen in terms of how they're thinking about building their applications. And I don't necessarily have the silver bullet fix that I can give you. But there are a few articles around this that I'll try and share maybe retrospectively. And once I write the article, I will try and share that out with you. It's a good question there. And it's sort of one of the weak areas of EventBridge. And Daryl, I see a question about EventBridge security. I'm not sure exactly what you mean by EventBridge security, so feel free to maybe add a bit more detail. I mean, it's all in your AWS account, so from that extent, it's owned by you. There is the option to have third parties sort of pushing events into EventBridge. So they're sort of partners working with AWS. I think Zendesk does it. I think a few payment providers do it. So that sort of opens a channel where events are coming through, and are they going through any authorization? It's an interesting question. It's not something I've played around with too much, but in general, these are events in your architecture that you've triggered somehow. Either that's a request that's come through a web client that a Lambda has then triggered an EventBridge event for, and obviously that event should be checked that it's authenticated as soon as possible. So preferably before it reaches the EventBridge. But I guess if you want to think about the security of those events after they've gone through, there's a question of how you process those by the resulting services. There's also, I think, a question around PII, so personally identifiable information. Seeing teams putting events through with quite identifiable information going through that bus. Now you can argue that that's fine because it's going through, it's all inside your AWS accounts. But there are maybe some questions around how you manage developers having access to that event bus, what data they're seeing, and audit trails around that. And that's not something I've looked into too deeply.
I had a quick question, Ben, which is around the positioning of EventBridge and in your architecture with things like domain-driven design. Is it sort of orchestrating events between and across the business domains, or is it also intra the domain as well?
Yeah, it's a good question. Depends how you define your domains. I'm working with startups, so very small domain in terms of they don't have 20 different development teams working in silos. They really have one development team building their system, but they're using EventBridge to handle communication between those services because they don't want to build that monolithic application straight away, and they're seeing a lot of speed from that. Obviously, you can argue that building a monolith straight away can give you a bit more speed, but they're because serverless has lowered a lot of the barriers to entry for getting new services up and running, they're seeing the microservice approach is helping them go quite quickly. I'm also seeing large companies using it in that sort of between different business silos approach, which sort of helps them share schema, not code, and helps lower the communication overhead. But yeah, I think it applies to both domains. I think people instinctively think of it for the enterprise domain, especially coming from sort of the ESB background, if you think in those sort of terms. But I think it applies sort of on the small service scale too. And I guess not something I've played around with, but I guess you could play around with the different services having their own internal event buses. It's not something I've seen done, but it's something you'd have the flexibility to do in EventBridge.